Hi, I'm Thomas Watson. I'm with Cleary Zimmerman Engineers. I'm a principal in our San Antonio office, and I'm here today to answer all the questions you have about MEP engineering. So let's get started with the first question. First question is, what does MEP stand for? MEP stands for Mechanical, Electrical, and Plumbing. And then the next question is, what are the primary responsibilities of MEP engineers in the design and construction process? I would say that boils down to making sure your client, the owner, the people using the building are satisfied when we walk away. So the systems we install, that we design, have to be functional. They have to be maintainable, and they have to serve a function at the end of the day. But they also have to, let's say, they have to work with architectural aesthetics. So we can't just go putting ductwork, piping wherever we want to. We have to make sure it looks good in the building at the end of the day. And then the next question in line would be, as a mechanical engineer, what is your main duty priority in your position? So I would say as a mechanical engineer, we deal with a lot of the bigger systems inside of a building. Ductwork takes up a lot of space. Our main responsibility is working with architects, making sure buildings work together functionally and aesthetically, and also making sure that owners can maintain their systems in the future, making sure systems work for what they need it to work for. Okay, so the next question. What are the main elements in a mechanical system in a building? So the main elements are, one of the big ones is ductwork or piping. So we have to be able to move air throughout a building. To be able to move air, you have to have pathways. So ductwork takes up a lot of space. A lot of times people don't see it because it's covered by ceilings and walls and chases. A lot of stuff that we design on a day-to-day basis, people don't see. So as you're sitting in a building, feeling air coming across you, that's the mechanical systems we're designing on a day-to-day basis. So what are some key considerations you take into account when designing an HVAC system? So that would be your ventilation rates, making sure that you have enough outside air in a building, that people are satisfied, it doesn't become stuffy. Making sure that the systems work as a whole, making sure there's enough area around them to maintain them. There's really a lot that goes into HVAC design. It's hard to put into just a few categories, but making sure it's functional, making sure it's maintainable, making sure you have the ventilation rates, and at the end of the day, the thermal comfort for the people in the building. How do chilled water systems work? So chilled water systems, this is one of my favorite questions. It's very similar, same components as you'd have in a residential DX split system at your house. You still have the refrigeration cycle and what's called the chiller. That's exchanging its energy with water. You then pump that water throughout a building, and then the water, you exchange that energy into the air that then goes into the space and provides the thermal comfort for the people. And the next question. So what is a central plant? A central plant is typically a building or a room or a space that basically houses a lot of the larger systems of a building. Say you have air-cooled chillers, generators, switchgear, all the big main components inside a building. A lot of times they'll live within a central plant. Central plants are usually associated with the larger projects, but not to say they couldn't be used on a smaller project as well. So the next question, what do you wish people knew about MEP? I'd say the biggest thing to that would be understanding the complexity of controls that go into buildings, whether it be on the mechanical side or the electrical side. Most people are familiar with just a single thermostat on the wall that does all the control. But when you get into larger buildings, the mechanical system controls, there's a lot of interfaces, a lot of if-then statements, a lot of stuff going on where one thing has to work for another thing to work. And the same on the electrical, on lighting controls. Just the complexity of controls that go into projects is something most people just don't understand. Could you discuss any emerging trends or technologies in MEP engineering that you find interesting or impactful? I think a big one going on right now is refrigerant. Every so often refrigerants are updated based on the efficiencies of the refrigerant, or say the impact of the ozone or overall global depletion. So one of the big ones is the newest refrigerant out. It's R454B. When I started in the field, it was R22. So there's been a number of iterations, R22, R410A, but newer one. So understanding how that impacts the design that we're going to take into account. And the next question is, if you had to describe how to become a mechanical engineer in 5 steps or less, what would you say? This is a tricky one because it all comes down to studying in school. So I'd say you have to get your college degree. In that, you have to study. Then once you graduate, you have to take an exam called the FE exam. That's where you become an engineer in training. And then the next step after that is taking the PE exam. You do have to wait 4 years. You have to have 4 years of field experience, actual designing systems to be able to sit for the PE exam. But once you take that, then you become a fully fledged professional engineer. What advice would you give someone considering a career in MEP engineering? So this is one I would say, take initiative. The answers aren't always given to you, especially in what we do day to day. The way you piece things together isn't always exactly the same as you did the last time. You have to be able to take what you learned from a previous project, a previous experience, and apply that forward and make sure it works for the function that you need it to. And on to our last question. What has been your most interesting project you've ever completed? That's a tricky one. I've worked on a lot of interesting, fun projects throughout my career, but I'd say one of the more complex ones would be a BSL-3 lab for Texas A&M University. Designing that project, there was a lot to take into account, the pressurizations, just the safety measures that go into that to make sure the occupants that are using those labs aren't in danger from cross-contamination, stuff like that, making sure everybody's safe at the end of the day. So thinking through those steps and how to make that work was really interesting. All right, thank you for joining us today. That's all the questions we have for today. Join us for the next round, and thank you for watching.